Hello, this is Dylan Chang with the final sprint of GAM374. So I'll start off just showing off the demo. The demo is not a full game. Unfortunately, I wasn't able to make a full thing, but it works for demonstration purposes. So this is the intro scene. There's the box. There's a box that when I press E, it will change the scene to my primary demo scene. So I press E, and it switches. As you can see, all of the assets are working. All the assets management clearly. The key inputs are working. I'm moving the ship with WSAD. I can shoot bullets with space, and the bullets have alarms on them. For them to die eventually, as you can see. And then there's collisions and stuff. The collisions work. As you can see, I'm colliding with the house right now. Pretty spot on. So, to get more into it, let's see, alarms first. So that box that changes scenes is still in this scene. So it's just out of the picture. So I'm gonna use that to demonstrate the alarms and how they work even when scene changes and stuff. So before that, I'll demonstrate the time management. So I'm shooting things, and if I press F10, it pauses the game. And as you can see, the bullets are not disappearing because the time is frozen. The alarms are frozen, and you can step by step do that. And then if you unpause it, the bullets will still exit the scene, and the alarms still work as intended. Also the alarms, if I change scenes when bullets are still active, the alarms will go off, as you can see from the output. So let's see. So everything's exiting the scene, and then the bullets are called to exit the scene by the alarm manager because the scene is ending. It knows the scene is ending, so it just tells all the alarms to go off and and say, stop existing, bullet. So yeah, and then let's see what else. Collision. Yeah. All right. Well, let's go into the code. I may come back to this to demonstrate more. So first off, assets, very easy. All of them look like this: models, shaders, and textures. They are singletons, I believe. Yeah, singletons. And they all just basically have storage sets or maps. They have maps. Yeah, they have maps. And they store the string as the key and all that stuff. Basic. They have accessors for the model if you need them, or the shader, or the texture as needed. And those things are called in the game load resources that the user will define. Here, very basic. They just load the models and stuff in. Anyway, time management. So this is the time manager. Very similar to your code. It has access to the freeze time tool, which allows you to go frame by frame. And as you saw, it works with the alarms. They stop when the time is frozen, and resume when the time is unfrozen. Camera controls, very basic camera manager. Yeah. So scene stuff. So this is where a lot of the managers obviously are converge in their functionality. So the scene manager is a singleton, um, and what it does, it obviously manages the scene. The scene manager handles the introduction, the when scenes come into play and when they are deleted. Um, I guess it would be better to show the scene first. So scenes have all scene level managers: updatable, drawable, alarmable, keyboard, event, collision, and the broker and the camera manager. So basically all of the game object managers that I'll get to later, um, and the camera manager and the broker for commands. So the scene basically just um, handles creation of all the commands from all of the game object managers. It handles updating the process of elements of each of those managers in the draw, and it also adds game objects to the scene or removes them from the scene. And then it also has this that is called when the scene is changed, which just signals for all of the managers to delete their pointers to whatever they handle, and set them up for actual deletion. So here's also the collision stuff, templated stuff, the commands as usual, and then the set collision and set collision supplier and self. Yeah, I'll get to this when I get to collision. And so here's what the user does to the scene. The user just defines game objects that they want. They make new game objects. They can also set up the camera. They can add game objects to the scene. They can set the collision stuff, and then in the scene end they call for each game object to mark for scene end. I have delete there because I was testing something, but it should be marked for scene end, and it works just fine. So back to the scene manager. The scene manager, whenever a scene is called to change, it calls the current scene's scene end, which is the function that calls all of the scene level managers to delete, and then it deletes the actual scene, which calls the destructor of the scene, and then it initializes a new scene as such. Yeah. So let's see how that works. Let's see. The command system, obviously there's the command base, and then all of the deregistrations and registrations. All of them are basically the same. So the scene change is the one we're interested in right now. So yeah, when the command is sent by the, let's see, it's sent by the scene manager to set the next scene. It makes a new command, scene change, and it waits until it's ready to execute, and then it executes. And like I said, it calls for the current scene to end. It deletes the current scene and then sets the new scene, which calls initialize on the next scene. So. So what's in so the initialized scene is written by the user. It's this, and then the deletes are all in the managers. So let's just show an example of that. So this is the updatable manager. So it just clears the set of updatables that it is in, and then make sure everything's all the pointers are gone. Let's try to find a more complicated one. So this one is the collision manager. When the scene calls delete on it, it will delete all of the things in the test commands set, which is where all the collision pairs and whatever are. And then it calls delete for all of the collision the collidable groups to delete, and then it clears, and then it says it's deleted. So yeah, all of the scene level managers have a similar function to that, where it just deletes all of the various data that it needs to correctly. So all right, let's go. Let's get to the game object stuff. So the game object is itself is pretty simple. It gets info from updatable, all the ubles, updatable, drawable, alarmable, inputable, and collidable. It has a scene entry and a scene exit, and those are defined by the user. And it has, yeah, that's just it. And so the mark for scene exit just tells the current scene to create a command to remove this from the scene, which calls the scene exit function that the user will define. The set scene is called when the game object comes into the scene, so that it knows what scene it's in, and then it has just a utility for getting the scene camera. So going to the ubles, the drawable and like updatable and whatever, they're all simple. They have generic functions that the user will define in their game object. So moving on to the more complicated ones. First, let's do the alarmable. So the alarmable has all three alarms. It has a registration system with with alarm markers, and the dispatch, which the alarm marker will call when the alarm is up. So the alarm marker is put into the alarmable manager. Actually, here, I have a class diagram for this. Alright, so the alarm marker is put into the alarmable manager, and it the alarm manager handles like what time these will go off, and that's put in as their key in the map. The alarmable manager works with the time manager to see when the time will go off. And when the time does go off, it calls the event. It calls the call event function on the alarm markers necessary, and the alarm markers then call in the call event function call dispatch, which will call the user-defined functions needed. And that's basically it for alarmables, I believe. So next is inputables. Inputables are similar to, I mean, they're not that complex, but they have a key pressed and key released for the user to define. They register the key event by putting in the key they want and the input type. So in the keyboard event manager, which is the main scene level manager. The keyboard event manager has a map of single key event managers. The single key event managers will track progress for what it says a single key, whether it's pressed or released, and then it sends the information back to the keyboard event manager for it to like process things. So, or wait. Oh no, the single key event manager calls the key pressed on the game object. So, yeah, yeah. So when a key is registered, it creates a new single key event manager and puts it in the map, and then registers the key into the single key event manager. And in the single key event manager, it just checks if it changed states between updates, and if it did, it calls key pressed or key released, depending on what was being monitored. I think that's all for inputables. So next is collidables, the most extensive system probably. So collidables have bounding sphere. It's templated. Yes. So the collidable definition here, it works with the bounding sphere, and yeah. Well, here's the bounding sphere. So the bounding sphere has can compute the how big it should be based on the model and the position on, and the bounding sphere calls the math tools intersect, which is what computes whether the bounding sphere is intersecting with another bounding sphere. Yeah, so here's the math tools. This is just the math. It should be pretty on point. It seems on point to me. Just looking at the demonstration. I mean, yeah. So there's that. And then collidable groups, which are managed, I believe, managed by the no, they're not. No, the collidable groups are singletons, multitons that are created by the scene? Question mark. Let's see. No, they're they're created whenever yeah. They are created by the scene, I believe. Yeah. So they're created whenever the the user says the collision manager should set a collision pair, which is in the user-defined scenes right here. So when this is called, the scene will create a new collision pair with two collidable groups, and then the collidable groups will also get a shutdown command for when they are deleted, when the scene is ended. So the collidable groups, they they're just there to have the the collision data, or what needs to be collided with, or what should be tracked with. And so the collision manager actually handles that. The collision manager has two sets of things. One for what it needs to check the test the test that it needs to check for, and like calls execute on those every update, I believe. And the set of delete commands is called only when the scene is ended. Yes. So here's the commands for collisions. The delete command, like I said, is called whenever the scene is ended, and it just deletes the collidable group. These just register collidable groups, or create collidable groups to be registered. And then here's the definitions for the calculation for the comparisons between whether or not two registered objects are colliding or not. And this is for whether they're colliding with itself or not. While we're here, I'll demonstrate the extra thing that you wanted to see. So right now, there's one spaceship in the scene, and it's not colliding with itself right now. It's registered to collide with to check for collision for spaceships. So if I put, another spaceship in, so there's two spaceships going to be in the scene. They're going to be right on top of each other, but they're there, and you will see. Let's just put breakpoints there and there, and then put a breakpoint in here, just so it is clear that it goes through. It checks only once. So it says there's a collision with the spaceship, and then it says there's a collision with the spaceship again. Why did it changed scenes for some reason? So anyway, why did it change scenes? I don't know. So yeah, so it went through the thing and checked if it collided with itself, and it did because they're right on top of each other. So it went and did that, and then it says collision detected, and it only checks once, even though there's two spaceships on the scene. So to test that there with three, I will add a third spaceship, and you will see only two tests will be processed here. So there's a collision with the spaceship, and then it will check for the collision with the spaceship with the third one, and it says there's another collision. It changed scenes again. That's weird. So, it's probably because there's another box in the scene, and it read that the E was still pressed when the scene changed, so it changes the scene again. Whatever. So as you can see, there's only two collisions detected, which makes sense because there's three spaceships, and so it only checked twice. And so, yeah, that's how that works. It works. So let me get out all this. Anyway, where was I? The collidables. I think I explained the collidables enough. Is there anything else? Oh, the visualizer, which is a singleton. It just renders the bounding experience, and that's basically it. It's called by the user, I believe. Yeah, when they draw. Spaceship. Yeah, when they draw. So, is there anything else? Went through all that. The scene registration broker. This is owned by the scene. It's where all the commands go through. Obviously, whenever any commands need to be taken care of, it adds it to the list, and then executes it when the game updates in the scene. At the beginning, let's see, class diagrams. This is the alarm system. This is the collision system. This is just everything I went over. Yeah. And here's the main engine thing. So it get tolls and initialize and load resources and update and draw. And then it deletes all of the singletons that it needs to, and then it deletes itself. This is where all of my documentation is. Yeah, we don't need to see that. Here's the big class diagram. You can't really get much out of this anyway. And here's the input system. Yeah, I went over this. So example scene. We already saw this, and then an example game object. Registers all the things in the scene entry, deregisters them all in the scene exit. That's called on mark for scene exit. Sets up all of the stuff needed in the constructor, destructor, just making sure all of the things are deregistered. They should all be called if you call mark for scene exit, but just making sure. Update, draw, has the key press and key released. So yeah, that's very basic. What else? Okay, so I guess now is the documentation time. So here's my documentation. For my user guide, there's just a very quick beginner's tutorial. It tells them to first make definition for load resources, and then a definition for game initialize, which are both needed, obviously. And then it tells them how to set up the first scene, which is just, I'm using my intro scene as an example. Here's the header. It's just very, very basic. Then the definition shows all the includes and stuff. And then it shows them an example game object. This is the box that I have that rotates, and then if you press E, it changes scene. So here's the header, and then here's the definition. Shows all of the includes that it needs, shows scene exit, scene entry, and the key press and whatever. And so yeah, there's the very basic beginner's tutorial. In modules, I have the things that the user directly interacts with at the top under user-defined game object and user-defined other stuff. So this user-defined game object contains all the ubbles and the game object, so they can check that if they want. But it has all the functions that they can define out here, so they know which ones they should define if they want to. Well, scene entry and exit they need to, but yeah, it just has them there. The user-defined stuff includes the load resource and the game initialize, as well as the scene stuff. And here's just the function definition documentation. Here's the game object, and as you can see, like, it shows the function documentation for like collision, and draw, and like key pressed, and just shows sample code for all of it, for when the user needs it. Here's back to the other stuff that they need to define. Examples of the scene initialize and like load resources and game initialize and whatever. And then other stuff for them to know, the game object managers, the asset managers, the other managers, and internal stuff are all modules. And all of these classes have definitions or documentation for each of the functions here. Most of them just have basic things because the user won't need to know about this most of these functions because most of them are internal. But the ones that the user does need to know, I put some extra documentation like parameters and whatever. Let's see. So, yeah, there's the camera manager and whatever. And then all the internal stuff also has the basic descriptions of the functions. And yeah, I think that's it. Yeah. Let's run the demo one more time. And just look at the output. All right, so the box enters the scene with this scene, and then I change the scene. The box exits the scene. The collision manager is deleted for that. Note that I just have a message for the collision manager, but all of the scene level managers are being deleted. Right there. And the spaceship enters the scene, the box enters the scene, and the cottage enters the scene. They register collision groups for the spaceship and itself, and the spaceship and the cottage. Those are two registered. Oh, like I said, because the scene changing box is still in the scene, it'll change the scene as long as I'm pressing E. So, but as you can see, when it changes scene with collision groups registered, it'll deregister all of them correctly. Yeah, that's about it, I think. Oh yeah, there's the message for collision with. Oh god. Yeah. Yeah. Whoa. That's bad.